A next obvious improvement of the plot concerns its labels. As you see, the default names for the axes are the names of the variables. But if you show this to somebody who is not familiar with this data set, it doesn't look very professional. So what we would like to do is we would like to change the labels of this plot. And to do so, we can use the function labs. Now, I want to show you something that is often useful when you develop plots interactively. So what I've done here is I always created the plot, the new figure from scratch, right? By having here the name of the plot, the association, and then here the creation of the plot. You can also do is you take the name of the existing plot object. So if you call that name, you basically see that the plot gets rendered over there. You then directly use the plus operator, and then you call your new function. So in our case, we want to add labels, so we use the function labs. Here we can add a title, like, for example, life expectancy and income per capita. We want to change, we want to have a caption in the lower right corner, like to indicate that the data comes from the Gapminder data set. And obviously we want to change here the labels for X and Y. So we have X equals GP per capita in international dollars. And we have for the Y-axis, we have life expectancy in years. Now, if you execute this, you immediately see the change here. So the code gets executed and the new plot gets rendered. But you need to be careful. If you now re-render this plot, you go back to the original version, because here there has not any association has taken place. What you can do, of course, is you update the plot in this case. So if you do that now and you now call the plot, it's the updated version. But you need to be careful, because this always operates on ggplot as it is in the current state in your working environment. So if you now do any other changes and then later you look at the code and you think, okay, if you write this, it's that plot, but you executed some other code, might be confusing. So my recommendation is to not do that, to use that while developing code, but otherwise be explicit and do the thing from scratch. But here, this interactive version is often useful for developing code. Let's get back to that. The other thing we would like to do is to change here the scaling, basically, of the x-axis, because these large numbers are not terribly well to read. What we can do, we can use a class of functions that all refer to the scale used in the plot. So not surprisingly, they start with scale and then an underscore. And then it's the axis or the part of the plot that you want to change. So in our case, we want to change the x-axis. We need another underscore. And now you need to specify the format or the kind of data on the x-axis. This might be a little bit confusing because not all of these are mutually exclusive. In our case, the variable GP per capita is continuous. So we need to use the function scaleX continuous. And then we can basically change everything that has to do with this scale. Like, for example, changing the limit, changing the extension. In our case, changing the breaks. As you see, many different things. In our case, we want to change the labels. So what is printed over there. And we want to reformat basically these numbers. So we don't want to change them. These should still be the numbers from the data set, but they should be reformatted. If you want to do that, you should use this package scales that contains useful functions such as number format, which has been very popular, but as you see, it's superseded right now. But you will still see this function a lot in documentation. Now you can use the more modern version, label number. And here you can change things like, for example, the scale. So in our case, we want to print it in thousands. So everything here should be multiplied by 0.001. And we want to add a suffix. The suffix should be k for kilo, for 1000. And if we execute this, we now see that we here have the much nicer labels printed. Now, to make sure that all this here is adequately recorded, we can now turn from this kind of interactive writing to the more complete writing by basically taking the code here from above, copy pasting it, make the addition to it explicit. Now, if you see the indentations are not right, you can just cut and paste, and everything is fine again. Regarding the line breaks, is a little bit taste also what you like. Here, the scales package is something that I should add here in the beginning to make sure all packages are mentioned there, up there. Okay, so then now move to the next step. Usually it's a good idea to have a look at the figure and think about, okay, what do you want to change? One thing that's still definitely not very nice in this context is are the labels. So one thing here in this context, for example, the size label here, that's not really useful. So what we want to do is we want to adjust the legends. Let's first try it out interactively. To be very honest, I actually think it's best to just get rid of this label here for the population. It's not very well readable, and nobody will be able to basically compare the sizes of the bubbles here in the plot with these sizes over there. So we should just remove it. To do that, we can again use one of these scale functions, but in this case, we're not referring to one of the axes, but we're to the scale size. And here, since we are talking about population, we again have a continuous variable. And what we can do is now we refer to the guide. The guide here in this case is the legend, and we want to have no guide. So we can try that out. And we see, okay, the guide has vanished. Obviously, we also forgot to execute this over there. If we execute it now, we have the plot as we wanted. There are also different approaches to achieving the same thing. There's, for example, also a function called guides, and here you could specify the guide for sizes. So in this case, you could run the same thing, and you get exactly the same result. It's a little bit the question of what you want, but situations like this where you can achieve the same goal with different functions are basically quite frequent, especially in these more specific situations. But one advantage of using the scale size continuous function here is that we can adjust other aspects of the size mapping here in the plot. Right now, I would say that the difference between the sizes of the plot is rather small. This concern is because of the limits of the sizes that are used in the plot. You can experiment with different ranges used by providing vectors with a lower and the upper limit. You can experiment a little bit with that. So if you, for example, choose range between 0.1 and 4, you see, okay, the bubbles become smaller and the difference is also smaller. If you add the 10, you can play a little bit around of what you like. I think I ended up in the end with 0.1 to 24. It's a little bit a question of taste of how it looks like. If you later save the figure as PDF or PNG, you also need to have a look at how it looks there. It's really more a trial and error thing. But this actually already looks not so bad. Just one thing that also concerns the legends would be that I guess it would be nicer to have this legend not to the right, but rather to the bottom of the plot. To this end, we can introduce a function that that's for me, it's a little bit like a garbage function. This function is theme because it basically allows you to adjust all these smaller details in the plot. So if you want to adjust something in the plot where you don't know where to adjust it elsewhere, theme might be a good place to search for. One thing that you can do in theme is that you can adjust the legend position. So in our case, we want to put the legend to the bottom. So this already looks much nicer. And then the question is also, okay, do we maybe want to change the title of the legend as well? So in this case, could also have a look at legend title. And if we want to remove the title, we need to use these kind of element function. These element functions allow you to change things like lines, rectangulars, texts, etc. If you want to remove something, you need to call this function element blank. So if we do that, we see, okay, the title of the legend goes away. Okay, so I think this is nice with regard to the legends. So again, we can copy paste our code here from above so that we actually adequately have the plot created from scratch. We see that it actually works out. Now we want to adjust some further details of the plot, and one thing that it is immediately striking is this weird gray background that is basically the default theme in ggplot2. And to be very honest, I don't know why it's still there. I don't know whether it's some kind of nostalgia or so. There are actually a lot of nicer themes that you can use as a default option. The themes are usually called something like theme, and then you have a lot of different options here. There are also a lot in the internet. You can use, for example, the theme black-white thing to get rid of the gray background. One thing you will notice now that some of the changes we made before are reversed. Like, for example, here we spent some effort in having the legend on the bottom and having the title of the legend removed. But now the legend is there again. And this is because the position of the legend and the kind of the text for the title of the legend is part of the theme BW black-white theme adjustments. So in this case, if you want to still keep your personal theme adjustments, what you need to make sure is that you call the general theme before your individual adjustments, because then it's not the general theme that overrides your adjustments, but your adjustments that override the general theme. So in all these cases here, the sequence of function calls doesn't matter at all. But it's here in the theme where you basically make contradicting statements where the latter statement takes precedence over the earlier one. So if we look at that, we basically keep what we want, but we also have the nicer general default options of the black-white theme. Although there are still some things that you might want to change, like for example the panel border here that appears to be superfluous. So let's remove that by calling element blank. Now we have, if you compare, this looks a bit cleaner, but still we might want to keep the axis for x and y. So in this case, we can then use the axis line, and now we need to draw element line, and here we can choose the color. So here we could choose, for example, gray. So this now looks a little bit nicer. It also shows, however, that these ticks here, they are a little bit of an irritating element. So what we can do here is we can adjust the legend ticks. Again, say element blank. No, it's not the legend ticks. It's actually the axis ticks. Sorry. So if we then execute this, you see that these irritating ticks, that they go away. So I don't want to go into further details with that, but what you see is that with this function theme, you can basically change all the nitty-gritty small elements of the plot that you can ever think about. Okay, so last thing that I want to change is basically this color scheme here. I mean, it's not very ugly, but it's also not particularly nice. This is also a skill you definitely need for procrastination, because there are few things where you can spend more time on than choosing the right color scheme for your plot. So there's a little bit of truth in that, so please don't waste too much time into that, but still choosing the right color theme can make a huge impact on the quality of your plot. So in our case here, we want to adjust the color scheme for the fill aesthetic, so we use the scale fill function. Now you might say, okay, it's something like scale fill discrete, because we are talking about the different categories, continents that are represented here. That's true, but since we want to choose a particular color scheme, we can basically use this more specific function, scale fill brewer, which allows you to use color schemes from the so-called color brewer package. So this is something you can easily look up in the internet. In this function, you basically choose the name of the palette. You can have a look at the different palettes in the internet where you get previews for that. I think the one that I used for the plot here in the first place is the dark 2 one, which I think here looks quite nice. Again, you can experiment with this in interactive mode. Then you can copy paste the code and basically put the scale here to the adequate position in the plot code, and then execute it. Now that's basically it. I think for that plot, this one looks quite nice now. There are still things you might want to change, but I guess this is something that's good to go. Now what we now need to do is to basically save the plot, and you can do that in a variety of different formats. Most of them are supported using the ggsave function. Most important here is the file name. Here in our case, I used the here function to put something in the output, say liveexp.pdf. By using the ending PDF, I automatically tell ggsave the format that should be used. And then I need to adjust things like the height. In my case, let's try height and width with 6, and many other options that are more or less useful depending on the file format you use. Now you might wonder, okay, how do you know which height and width value you should use in this context? It's again a little bit trial and error. So what I usually do is I use ggsave and then go here in the folder where I have created the plot, then click on it and have a look. So in this case here, this doesn't look very nice. It would be nicer to have it wider and maybe less height. So what you can do is you maybe just exchange these. You do it again. You again have a look at the plot. Okay, it doesn't, still not very nice. So we could have like, 7 and 4. It's a little bit of trial and error thing until you have something that you basically like. If you use it for a presentation, you might also insert it and then redo it. So that's really trial and error. But ggsave is basically a good way to save your figure. There are also more advanced functions, especially when you want to have, for example, several plots in one figure, etc., etc. But I guess right now you get the basic idea, and from that, it's also much easier to get to know about more advanced functions, because if you understand the basics, you can search very specifically for changes required.